If you've watched the previous video when I did the AM alignment of this Grundig 3060A, you may recall that I mentioned I may not do the FM IF alignment because the reception was actually exceptional. But because I want to do this completely and because I'm a sucker for punishment, I decided to go ahead and do it anyway. Alright, so basically what we need to do here is we need to align the three IF transformers on this radio that deal with the FM IF to maximum response. Okay, now the IF FM IF for this radio is 10.7 megahertz, as is quite usual, and we have three transformers to deal with, starting from the one nearest the RF stage, the radio reception stage. We have this one over here. So that is the first stage. We've got two cores on there. One is labeled F and the other one's labeled G. So that is the first one we do. That's called F1, filter 1. So we need to align that for maximum on the IF frequency. The second one coming forward is this one over here, which is labeled F2. And that has got coils D and E, and we also have to max those two. And then the third one, and the most important one, is this one here, which is F5, FV. And this one is slightly different because it has the discriminator coil in here, which is this one over here. And if you recall, this one is treated differently because this is the one that you use to balance the signal and therefore allow the detector to do its job. So what you normally have to do is you need to unwind this core, in other words unscrew this core as much as possible, usually till it's almost popping out, so that you can get a better response on those, and it makes it easier for the alignment procedure. Now the way to do the alignment is you send the signal from the signal generator at 10.7 megahertz unmodulated. That's your FM carrier. That's the IF frequency, so it goes in and you coupled it lightly to the ECC85 tube. The way to couple that I'll show you in a minute. And then you keep tweaking these cores till you get the maximum response. And the maximum response is shown by a negative voltage at this discriminator capacitor here. So you connect a voltmeter to ground and to that point of the capacitor, and you're measuring a negative voltage. The more negative it is, the stronger the signal. Okay, so usually I use the avometer with reverse polarity, so I see it as a positive voltage, but I'm actually measuring a negative voltage. All right, so let's set that up. I'm going to unscrew this core completely. I'm going to set up a signal generator. I'm going to couple it and show you the procedure from there. So the signal generator is producing 10.7 megahertz. The amplitude at the moment is 40 millivolts RMS, but we can adjust that, and we will do, and I'll show you, because it'll depend on what sort of coupling we have to that FM tube. And when we hit that, we have the signal going through. The coupling of the signal to the tube in the FM can is done. I just wind a few coils of wire, just normal coated wire on here, around here, put this in a former, just a piece of paper and tape, and just lightly push it over the tube. Okay, so it's basically very light coupling, and the positive of the signal generator signal then goes to that. The negative of the signal generator signal I've connected to ground, and that should be enough coupling for us to get our signal through. Right, here we have it. We've got the voltmeter DC volts connected across that discriminator capacitor. It's a negative volts, so I have got reverse meter movement on here. And what they suggest is you set it till this reading is approximately 2 volts, and you start at about 2 volts. So what I'm going to do is I'm going to adjust the output level, the amplitude of the signal generator, increase that a bit, till we get about 2 volts. We're at 1.4, about 2 volts on there. Doesn't have to be exact. There we got it. Well, there's about 2 volts on there, and now we're going to adjust the cores on the other cores that I've mentioned, starting with the one that is the pair to the discriminator core that I've unwound completely, and we peak it. And I've tuned the radios on FM. The volume is just hissing away. Putting the volume down, we don't need to hear that. And I'm peaking it at 10.7 megahertz. Okay, so going to that top core. Now it's going down. There we go, there's our peak. There's our peak. Whoops. When you remove it, sometimes it changes slightly, because what you're doing is you're putting less pressure on that core. So you've got to do it very gently. There we go. That one's peaked. Moving on to the next one, the one that's part of that dual IF transformer. We're going to peak that one as well. Wrong way. That's about our peak there. There's our peak. Now the top section of that. There's our peak. Okay, one thing to note, you don't need to worry if this drops somewhat. What's important is that when you are tweaking it, you peak it. If you move away or you adjust the position of your body in front of the radio, the actual coupling between that winding that I've used to couple to that tube may change somewhat. So it can, if I twiddle that winding around, it can actually change a little bit. What you need to worry about is at the moment that you are tweaking it, you are peaking the voltage over there. Now, this is already at 3 point something volts, so I'm going to reduce the amplitude of the signal generator again till it's around 2 volts. And we're now going to peak the last IF transformer. In other words, the first one closest to the RF section. Just a little change over there. Okay, now the top one. There you go, it's peaked. Okay, so we've peaked the IF transformers, and we've now got one task left, and that is to set the discriminator coil for its optimum position. Now I'm going to try the 2 resistor trick and see if that works on here, and we'll follow from there. So to adjust the discriminator coil, what I do is I've made up 2 resistors in series that are basically, they're identical resistors as close as possible to in value, and those 2 are connected across this discriminator capacitor. It can also be across from there to there, but I've done it across the capacitor. And what I've done is that this has a resistor. There's another resistor here connected to there. These are 100K each, very closely matched. It's more important that they're closely matched than their actual value. They can be anything above 68 or 120K, whatever. And then I connect a microammeter from there to this output of this coil over here. So the output of that coil over there, which is the best way to find it is to follow that line and see where it goes, and I know that it goes to a particular resistor over here. So I then adjust this core, and what I will find is that the current, if you have zero current there, the current will actually peak, come down, and peak again. And I need to stop it there, where you have 0 microamps flowing. Okay, so when I start screwing in that core, I will see the current start increasing, and then I will see it drop. And then if I reverse the meter, because I don't have a center 0 meter, I will see that it'll peak again on the other side. So I come back and I stop over there, and I should have that perfectly tuned. Let's see how it goes. So here we have the meter set on microamps. This is actually on the 50 microamp range, DC microamps, wired as shown in the little drawing I did before, and I'm going to start screwing this core in. As you can see, it's rising, and it should peak and then drop down to 0. There we go, peaks, and then it actually drops quite fast relative to the number of turns you make. Now when it gets to 0, it goes negative. Because I don't have a center 0 meter, I just reverse the polarity. So when it's going up now, it's basically like it's going negative on the other side. So it's going to peak again, and then it should come down. There we go. So I know that where it crosses 0, I go back now to that 0 point there. Let's look from the top, and it's exactly on 0, and I know that I am adjusted. So I should have that discriminator coil perfectly adjusted. Okay, let's put it on and see what the reception is like. I've put an antenna in the back. It's on FM. Put the volume up and see what kind of reception we're getting.
Estou consigo na Antena 1. Bom regresso a casa. The Gift, música nova, Clinic Hop, produção de Braun Atelier.
Lugares para voar entre 1 de fevereiro e 5 de julho de 2017. Why not? Terminam hoje à meia-noite, easy.
No passado são acontecimento presente e permanente em cada missa celebrada.
All right, no distortion. The antenna is not very good, so really clear FM I get at about 2 stations. But where I do get it absolutely clear, there is absolutely no distortion. So I believe this thing is now as perfectly aligned as it's going to get. One more thing you might have noticed is that the Magic Eye tube is working. I had to replace that, and I replaced that with the Russian version. This radio comes with an EM3435 Magic Eye tube, and those guys are very difficult to get, and they're pretty old. It's this guy over here. This one was completely dull. You could hardly see any of the green coming through, so obviously it's run its course. Now, to find one of these guys is not difficult. To buy it, it is. They're extremely expensive. I've seen them sold for 70 to 100 euros on eBay, and I'm just not prepared to pay that kind of money for a tube, a Magic Eye tube, especially when there's a cheaper alternative. This is the 6E5C. It's apparently a Russian equivalent, and while they say it's equivalent, it's not quite. It's equivalent in terms of B+ values, approximate grid values, voltage levels, and so on. In other words, the sensitivity is actually a little bit higher than the other one. You may get the eye closing completely, whereas on the EM34 it might just be slightly open. So you might want to reduce the sensitivity of that. I've never done that. I've left it as is. But you do need to change the wiring. The actual tube socket is identical, and you get a whole lot of drawings on the web showing you exactly how to wire it up, how to change the wiring from the EM34 to the 6E5C. And the result is fantastic. I mean, this thing costs about $7, $8, $9 as opposed to 10 times that. And the only difference really is that you have one eye opening as opposed to two. On the EM34 you have two gaps sort of opening up, one opposite the other, and in this one you have one, and you can see it opens, it closes as it tunes in. It's pretty responsive, and it gives the radio that extra bling which everybody seems to like on a tube radio. Most people don't even know how to refer to tube radio. They just say, you know, the old radios with that green eye on there. At least that's what they do here. Anyway, so that's done. That's the Magic Eye tube working. So what we have now is actually the radio is complete, and the only thing that needs doing is the cabinet, which is going to be not so much of a job. I think all it needs is a new layer of lacquer, so I'm going to sand it down with wet sand it with very, very fine sandpaper, probably 1000 grit or 1200 grit. I'll get everything polished up and shiny that needs to be shiny, and give it some lacquer, and when I've got that done, I'll get back to you and show you the result. Bye for now.